Vertical asymptotes. The line x equal to a is a vertical asymptote of the graph of the function y equal to f of x if at least one of the following statement is true. Limit x approaches a from the left equal to positive infinity, or limit x approaches a from the left equal to negative infinity, or limit x approaches a from the right equal to positive infinity, or limit x approaches a from the right equal to negative infinity. For example, if we have a function 2x over x minus 1, this is the function 2x over x minus 1. Then if we draw the graph, it will look like this. This is the graph of the function 2x over x minus 1. It is actually a reciprocal function. So, if you could see from the graph, when x approaches 1 from the left, so the graph is approaching downward until the value of negative infinity. And when the graph approaches 1 from the right, it's going to be closer and closer to positive infinity. Thus, we could say that x equal to 1 is a vertical asymptote of f of x. Horizontal asymptotes. Horizontal asymptotes are the horizontal lines that the graph of the function approaches as x approaches positive or negative infinity. The horizontal line y equal to c is the horizontal asymptote of the function of y equal to f of x if limit x approaches negative infinity for the function is equal to c, or limit x approaches positive infinity to the function equal to c. For example, if we have the function 2x over x minus 1, then as x approaches positive or negative infinity, fx approaches but never quite reach the value of 2. Using limit notation, we state limit x approaches negative infinity for 2x over x minus 1 is equal to 2, and limit x approaches positive infinity to x over x minus 1 also equal to 2. Thus, y equal to 2 is the horizontal asymptote of f of x. Example 16. Compute the vertical and horizontal asymptotes of f of x equal to 2x over x squared minus x minus 2. So first of all, I'm going to find the vertical asymptotes. So to find the vertical asymptotes, we are going to simply making the denominator equal to 0. So denominator for the function is x squared minus x minus 2. Make it equal to 0. Since we end up with quadratic function, we're going to factorize it. So we get x minus 2x plus 1, thus x equal to 2 and x equal to negative 1. These are the two vertical asymptotes for the function. But we need to check whether it is really the vertical asymptotes. So to check, first of all, I'm going to check at x equal to 2. So to check whether x equal to 2 is really the vertical asymptotes, we're going to find the limit x approaches 2 from the right for the function 2x over x squared minus x minus 2. And as usual, we're going to substitute x equal to 2, which will give us the value of 4 over 0. So constant over 0 is equal to infinity, but it could be positive or negative infinity. So to know whether it is positive or negative infinity, we're going to substitute the nearest value. So if we draw a number line 2, x approaches 2 from the right, choose any value that approaches 2 from the right, for example 2.1. So if we substitute x equal to 2.1 into the function, we're going to get the value of 13.5, we're not interested in the value, we just wanted to know whether it is positive or negative. So in this case, we get positive value. So we could say that limit x approaches 2 from the right for the function 2x over x squared minus x minus 2 is equal to positive infinity. And then we're going to do the same for limit x approaches 2 from the left. Substitute the value of x equal to 2, and we also get 4 over 0, and the answer is positive or negative infinity. So to check, substitute any value that approaches 2 from the left, for example 1.9. So if we substitute 1.9 into the function, we're going to get the negative value. So here the value is negative infinity. Since we get both of the value, or positive infinity and negative infinity, thus we could say that x equal to 2 is the vertical asymptote. If it's asymptote, we're going to get the value of positive or negative infinity. Next, we need to check the value of x equal to negative 1. So for x equal to negative 1, check the limit x approaches negative 1 from the right for the function 2x over x squared minus x minus 2. As usual, substitute negative 1 into the x. Which will give us the value of negative 2 over 0. So when we have constant over 0, the answer would be positive or negative infinity. And as usual, to know whether it is positive or negative, substitute the nearest value. So if I draw a number line, negative 1 here, x approaches negative 1 from the right. So the value that lies on the right of negative 1, for example, is negative 0.9. So if we substitute x equal to negative 0.9 into the function, we're going to get the positive value. So limit x approaches negative 1 from the right for the function, it will be equal to positive infinity. And then we're going to do the same thing, but for limit x approaches negative 1 from the left. As usual, substitute x equal to negative 1. And we're going to end up with negative 2 over 0. Constant over 0 is equal to infinity. And to know whether it is positive or negative, substitute the nearest value. So choose any value that approaches negative 1 from the left. For example, x equal to negative 1.1. So when we substitute x equal to negative 1.1 into the function, we're going to get the negative value. So here, it will be negative infinity. So since we get the value of limit is positive infinity and negative infinity, both are infinity, thus we could make the conclusion that x equal to negative 1 is the asymptote. Is the vertical asymptote. So in conclusion, x equal to 2 and x equal to negative 1 are both the vertical asymptotes. Next, we're going to compute the horizontal asymptote for the function. So to find the horizontal asymptote, we need to find the limit x approaches positive infinity of the function to x over x squared minus x minus 2. As we substitute x equal to infinity, so we're going to end up with infinity over infinity. And when we have infinity over infinity, we need to simplify the function by factorizing the highest degree of numerator and denominator. So for the numerator, the highest degree is x, so factorize x, what's left is 2. And for the denominator, the highest degree is x squared. Factorize the x squared, so we're going to have 1 minus 1 over x minus 2 over x squared. And then we could just simply simplify x over x squared, and what's left is 2 over x, 1 minus 1 over x minus 2 over x squared. And as usual, after we simplify the function, we're going to substitute x equal to infinity. But since it's not proper to substitute x equal to infinity, we're just going to imagine it. So the numerator would stay 2, and for denominator, x here would be infinity. And then 1 over infinity will be equal to 0. Negative 2 over x squared, which means negative 2 over infinity squared, will also be equal to 0. So what's left is infinity multiplied with 1 minus 0 minus 0, which will give us 2 over infinity. So constant divided by infinity, we're going to get 0. That is for limit x approaches positive infinity. So here we could see that y equal to 0 is one of the vertical asymptote. And then we also need to find the limit x approaches negative infinity. For the function 2x over x squared minus x minus 2. Substitute x equal to negative infinity. Will give us the value of negative infinity over infinity. As usual, when we have negative infinity over infinity, we need to simplify the function by factorizing the highest degree of numerator and denominator. So for the numerator, we need to factorize x, so what's left is 2. For denominator, factorize x squared, which will give us 1 minus 1 over x minus 2. Cancel it out. After we cancel it out, so what's left is 2 over x, 1 minus x minus 2 over x squared. And then after we simplify it, we're going to substitute x equal to negative infinity. So here it will be 2 and then negative infinity, and for the function in the bracket, 1 over negative infinity will be equal to 0, 2 over negative infinity square will also be equal to 0. So it will be 1 minus 0 minus 0. So we're going to end up with 2 over negative infinity. So constant divided by positive or negative infinity will be equal to 0. So we can conclude that y equal to 0 is a horizontal asymptote of the function.